Hi, good morning, everyone. So let's continue our discussion from yesterday's lesson. So remember, we had a quadratic equation, x squared minus 3x plus 2 equal to 0. And then when we use the quadratic formula, we can get the solution or the roots of this quadratic equation. The first one was x1 equal to 1, and then the second solution x2 equal to 2. Now what I will do now, I can do like this. So here, if I have the first x equal to 1, I can put that number 1 to the left hand side. So what we will get is x minus 1 equal to 0. And I can also do the same thing here. So basically what I will do, I will move this number 2 to the left hand side. So I will have now x minus 2 equal to 0. So as you can see here, from the solution x minus equal to 1 and x equal to 2, we can get this term x minus 1, yeah, and then x minus 2 by simply move those numbers to the other side. Now, so what I want to show you now is that, what happens is when you have that quadratic equation, actually, we can write down this quadratic equation into its factors. So you see, basically this x squared minus 3x plus 2 is just x minus 1 times x minus 2. Yeah. So this is actually quite important because, sometimes when you have a quadratic equation like this, what happens is when you are finding the solution or the roots, you don't need to use the quadratic formula all the time, because sometimes when the numbers are good like this one, we can simply factorize this quadratic term. So here's the thing. Basically, when you look at the quadratic equation like this one, yeah. First of all, when the coefficient in front of the quadratic term here, x squared, is already 1, yeah, this makes our life much easier because, when this is already 1, yeah, and then you can now look at this number. So what happens is like this. You have to think two numbers, when you multiply them, will give you this value 2. So of course there are many combinations. For example, 1 times 2, or minus 1 times minus 2. But then what happens is from this combination you have to find the you see, when you add those two numbers to vectors, yeah, of this value 2, which one actually will give you this number minus 3 when you add those factors. So of course, when you add 1 plus 2, you will get just, this is 3, eh? And then when you add, minus 1 plus minus 2, this will give us minus 3, which is the same thing like this number. So in this case, you see, these are the number that you want to have here, minus 1 and minus 2, because look, when you have x minus 1 times x minus 2, and then you try to expand by multiplying them, yeah, what you will get, you see, x squared minus 2x, and then you multiply this and that, and then this times that will give you the same thing, which is x squared minus 3x plus 2. So I think this factorization technique is quite useful when you are doing, finding the roots or the solution of a quadratic equation. And especially where the numbers in that equation are quite simple, are quite easy, so you can find the combination that give you these factors, right? So now, so again, when you have the roots, yeah, x equal to 1 or x equal to 2, therefore x minus 1 and x minus 2 are the factors of the quadratic equation given here, x squared minus 3x plus 2. So this is actually something that we need to learn further, yeah? And the next part of today's discussion, I want to talk about the remainder theorem and also factor theorem. So let's look at the first one. When the polynomial of fx, yeah, is divided by x minus c, therefore the remainder is f of c. So what does it mean by this? Okay, look, what happened here is we have a polynomial, and the polynomial can be, you know, quadratic function or higher function than quadratic, you know, can be like cubic or higher, yeah. So in our case, let's just get the example from the previous example, yeah. So basically, our polynomial here, fx, it's just x squared minus 3x plus 2. So it's a quadratic function. Now, you know, when I divide this polynomial by a factor, for example, x minus a number, therefore the remainder of this division will give you f of c, of f of that number. So what does it mean by that? Basically, let's suppose you divide now the fx, you divide by you know, x minus, for example, x plus 1. So let's just divide this polynomial by x plus 1, yeah? So we actually doing this division now, x squared minus 3x plus 2 divided by x plus 1. Now the question is, how are we going to divide this? So when you are dividing a polynomial with the linear term like this, basically what we'll do is just similar like when we do the long division. So long division, remember when we do the long division, it's like when you do, for example, you divide, say 300 divided by 8. Now this is what you do, right? So 30 divided by 8, you will get, okay, 3, so this is the closest, yeah? And then, you know, next 60 divided by 8, so it's 7, and then you got 56 here. So what we'll get here is, we'll get 37, and then, you know, the remainder here is 4 and 8, yeah? Let me see the number again, yeah, looks right. So that's what we will get here. Now, when you are dividing this quadratic with this linear term, basically, we'll do something similar like that, yeah? So you divide by x plus 1. And you know how to divide this is quite similar. So the first thing is we divide this x squared by x. Now, when you divide the x squared by x, what you will get is you will get x, right? So x squared is just x times x, and then divide by x, one of the x cancel. So in this case, you will get an x here. Now, what you will do with this x, basically, you will multiply this with this guy and also this guy. So when you multiply the x with x, you will get also x squared here. And then when you multiply this x by 1, you will get a 1x, right? And then just like what you did with that number, you just subtract now to you know, to get rid of this x squared. So basically now what you will have here is minus 3x minus 1x. So that will give minus 4x, yeah? Now, you know, the next thing is you just pull this number down, yeah, plus 2 there, and then now let's do one more time. You divide now minus 4x divided by x, so minus 4x divided by x, you will get now minus 4. So put that number here now, minus 4. Now what you do with this number 4, minus 4, you will multiply it again with x and also 1, right? So what you will get is, it's, you know, minus 4x minus 4. There we go. What we will get here is, you know, 2 minus minus 4, which is 6, yeah? So this is the remainder actually. And now you know, to get the remainder, basically you can do a long division like this, but you see, if you look at again the remainder theorem, when this polynomial is divided by x minus c, yeah, the remainder is fc. So in this case, you need to know what this c is here. So if I have in general x minus c there, yeah, x minus c, and this is equivalent to x plus 1. So in this case, you can see that the minus c here, it's this value 1, right? So you see now, this minus c is just 1. And if minus c equals to 1, therefore, the value of c will give us minus 1. Now, let's try when you have fx equal to x squared minus 3x plus 2, and then I want to find this value f of minus 1. So basically what we are doing now is simply to put this number into this x, yeah? Right, so let's do that now. Okay, so minus 1 squared minus 3, and then times minus 1, and then plus 2. So this is what we'll get. So 1, and then, you know, minus 3 times minus 1, it's 3, and then plus 2. So in this case, you got that number here, which is the same thing, 6 here, like this one. So this is actually what the remainder theorem says. If you have a polynomial, and then you divide this polynomial by a linear term x minus c, therefore, the remainder of that function is just simply f of this number minus c. Yeah? So in this case, if c is minus 1, you just plug in that number f of minus 1, and then you will get the value of f minus 1, which is in this case 6. So I think this is what I'm going to discuss for today, yeah, the remainder theorem, and you can always try with the other values or the other linear term. For example, now you want to divide this quadratic function fx by, let's divide by x plus 2, and then you will do the same thing like this long division, you know, x squared minus 3x plus 2 divided by x plus 2, and then you want to verify whether the you know, remainder that you will get at the end, it is equal to f of minus 2. So you see, when you are dealing with the quadratic equation or quadratic function like this one, actually it is quite useful because you can use this for an example to give you an idea, and then you can generalize this idea for higher function. Yeah. So the only thing that I want to comment here is when you divide a polynomial by a linear term, for example, this one x plus c, therefore, you know, so when you divide this polynomial by this linear term x plus 1, yeah, therefore you have to be careful because in this case, this value of c is not 1, but it is minus 1, yeah, because what happens is you divide by x minus c. So it's like, you know, x minus c equal to x plus 1. Therefore, the value of c is just minus 1. So this is the common mistake that I find from students actually when they divide a polynomial by linear term. For example, x plus 1, and then what they put in that function, instead of put minus 1, they put f of 1, and that is different. That is not correct. So just be careful when you're dealing with what value of c that you have here, okay? So yeah, I think this is something that gives us a basic idea about so-called the factor theorem that we will discuss tomorrow. So thank you, and I'll see you tomorrow for factor theorem.